how we're going to use the rest of our work area to get the remaining samples. So we only kind of have a limited number of samples and a limited number of tries at this, so we want to plan it very carefully. And that's all I have to say, and I will now pass it off to the robotic arm team.
Thank you. The robotic arm has performed actually excellently and flawlessly for the past 9 soils. And we've been very pleased with the robotic arm. It's healthy, and we've been able to do a couple of test dig and dumps. And can we see the next image, please? So on soil 8, we did our first dig and dump, and we dug a depth of about, we commanded a depth of about 1 cm and the length of about 5 cm. It was done flawlessly, and then we dumped the pile right next to the dig area. On soil 9, what you're seeing is actual telemetry that came from the spacecraft on soil 9. I think that was yesterday. And we went to the same area that we dug the first area, and then we actually extended the length of the dig by 7 cm. So we went back, and then we did a 12 cm dig with the scoop, and that was also flawless. Next image, please. This shows the first dig area, an SSI image. Next image, please. And this is the image that came down yesterday soil, and this is, we went back to the same area, and we extended the dig area by another 7 cm, so we have a length of 12 cm or thereabout, and the depth so far is about 3 to 5 cm, depending, because we have a slope of about 15 degrees, so depending on a roll to the right a little bit. Next image. And we don't only utilize the robotic arm for digging, we do also use it to assess what we call lander stability. And on soil 5, we did command the robotic arm to do some rather extreme yoga or Tai Chi moves to look at the footpaths. And the last move that we did was one of the most daring moves we've ever made on Mars so far. And the image that we got from that using the robotic arm camera was actually spectacular. And I'm going to hand over to Uwe to describe that.
Before I show you this very spectacular image, I would like to go back to the first technical image we took on soil 5. Next image, please. Showing the easterly foot and leg of the lander, and right next to this the foot we saw a structure, a smooth slab, quite different from the rocks we see in the environment of the lander, which really excited us. And of course we wanted to go closer and have a closer look to this structure, which is now called the Snow Queen, and is shown in the next image. This image shows a lot of detail. It shows in the center a cavity, and in the meantime I can talk about this. We have a stereo imaging, and so we know about the structures we see. You see in the center a cavity, and this cavity extends to the gravel on the right hand side, where you see a little pebble, and this seems to be, the scene could be that this pebble has been thrown out by the thrusters during the landing activity and rolled down through the cavity. You can also see on Snow Queen, on this smooth surface, on the roundish surface, a characteristic ledge, which indicates a layering of this material. The ledges may be in the order of a centimeter high, and small pits can be seen along this ledge. And this is a material which is considerably brighter than the environment, than the regolith you see in the vicinity. And of course, we became very excited to see this kind of material. And the next image shows, or video animation shows you the activity of the arm doing some duties on top of the lander, going to the optical microscope, and then to TIGA, and then it, after it has done some pseudo deliveries, if you want to, into those instruments, it shows the activity looking underneath the lander. It's sort of like a giraffe looking between its legs. it's a complicated activity, and it's a complicated activity also for the robotic arm. And holy cow, what did we see there? We were all amazed, and we saw the flat surface, a bright surface, and which is shown in detail in this slide. You can see that the lander stands essentially on an extended hard surface, which is about 3 times brighter than the vicinity of the regolith. And you can see that this surface has been blown clear by the thrusters in the middle between the 2 thrusters at the legs, in the southern leg in the rear, and the easterly leg in the front. There's a ridge of material blown together by the thrusters, and the surface is rather smooth and extended. And this, I think, makes us thinking that this is the typical surface we are standing on. I think it's probably extending underneath the regolith, underneath about maybe 5 centimeters of regolith, and we could expect to see this while we are digging. And we will see then this is one activity of the RAC, of the robotic arm camera, is to look at the details during operation. At the end of the arm, we can look at areas the SSI can't look, and we can look at the details of the lander deck, and we also, of course, at the details where we do the digging. And we can look at the material we are digging out, as seen in the next image, the material in the scoop on Sol 9 on the last day from the second dig of the Dodo area. And this time you don't see any whitish material shown in this in the back of the scoop. The camera can resolve the details of the material in here. The resolution of this middle image is about 0.5 millimeter per pixel, and when the material comes closer to the blade of the scoop, then we can analyze the material in detail down to the fraction of the thickness of a man's hair. This is one topic to do, is to characterize the material before it's delivered, but on the other hand we can also characterize the digging area, as shown already and shown again in the next slide, where we look down on the trench, which the extended trench after the second digging, and the perspective is optimum because we almost look perpendicular to the down on the surface. There is no distortion due to the geometry, and you can see here that we indeed, for the first time, we saw in the digging area the white material at the bottom. You have to think about that the second time when we went into the trench, the blade scraped essentially across the bottom of the trench, and while it did this, it opened some white material to our view, and I think this is very probably the same kind of material, the same surface we have seen extensively underneath the spacecraft itself. So it's just corroborating the idea that this solid material extends all under the regolith seen in the vicinity of the lander. So this is all I have to say about the capabilities and activities of the RAC.